video lesson, what we're doing is revisiting the mini lecture. And the mini lecture that I posted on Blackboard was about understanding what we mean when we talk about the mean value of a set of data. Here on this board you can see that I've got 6 data values, and those are actually the same data values that were in the mini lecture related to student name length. And the 6 represents Hannah's name length of 6 letters, 9 for Elizabeth's length of 9 letters, Ben 3 letters in his name length, Ty has 2 letters, Jade has 4 letters in her name length, and Blaine has 6. Now when I present that data to students and ask them to find the mean, most students know that what they have to do is find the sum of the data, like we've listed here on the board. Adding all the data values together gives you a sum of 30, and then we take the sum and divide it by the number of data values, which is 6 in this case. 30 divided by 6 is 5. So this particular set of data has a mean of 5. And what we have up here on the board is the process that you use to find the mean. The mean is 5, which some students find interesting because none of the data values is actually 5, but yet we're saying that the mean length for the student name length is 5. But that's what the process leads us to. Beyond knowing what the process is, what I'd like for us to do in this video is think about what we mean when we say that the mean is 5. And in the mini lecture we talked about it in terms of a fair sharing, and I'm going to use the towers that you see here and the cups that I've placed here to talk about the idea of what we mean by a fair share when we're finding the mean. And then the scale that you see back here, I'm going to use that to be sure that you understand what I mean about the mean of 5 being a balancing point for our data. So let's first look at our towers that we have here. And with the towers, we have our student name length. We've got Hannah with 6 letters in her name, Elizabeth with 9, Ben has 3 letters in his name, Ty 2, Jade 4, and Blaine 6. So here are the towers that represent their name lengths, and when students build a tower that represents the number of letters in their name, what I then ask them to do is to balance out the height of the towers, to make sure that each student has the same number of cubes in their tower. And you have to use all the cubes. You can't have any leftovers, you got to use them. So sometimes students will just take their towers apart and start dividing them out. Others will simply say, Elizabeth, you've got lots of extra letters. Look, Ty doesn't have many. Why don't you share with him? And you know, she may not be sure at first how many to share, but she could share 3 letters with Ty, and still the towers are not the same height, so there's still some sharing that has to do, and maybe coming from Elizabeth, because certainly Ben's tower was not tall enough. But wait a minute. Hannah's tower is taller, so she could share a letter with Ben. And, well, they're not all the same height yet, but if we take 1 cube from Blaine and give that to Jade, what we've accomplished now is still we have 6 students, and they're represented with each tower. But now what we've done is we've leveled out each tower. We've used all of our cubes. And in fact, we had 30 cubes, and we still have 30 cubes. We haven't taken any of them away. We haven't added any more cubes to our towers here, but we've divided them out among the 6 students so that each student has the exact same number of letters. And what it looks like is that in each tower, each student has 5 letters. And that's what we mean when we say that the mean is a fair share. It's a measurement of a fair share. Even though each student had a different number of letters in their name, once they've shared all their letters, each student has 5 letters, and that's what we mean by the mean being 5. And that's with the tower model that I had here. Still thinking about it in terms of fair share, I've got these counters in a cup, and each student has the correct exact number of counters in their cup that represents the number of letters in their name. And the idea that it's 6 students and that they would have to share the number of counters that they have, certainly again, Elizabeth has more counters than everybody else, and she's going to end up sharing, perhaps taking 4 of her counters, leaving her with 5. And we can't put all of them in Ty's cup. We can put 3 of them in Ty's cup, and he's got 5. Jade has 4. We can put this extra one in her cup. Hannah still has 6, but I could take 1 out and put that in Ben's cup. He only has 4. Who's got more than 5? Oh, Blaine does. So we'll take one of Blaine's counters and put them in Ben's cup. So at this point, each student has 5 cubes, or 5 counters rather, in their cup. So again, what we've done is we've taken 30, because that's how many counters there are. That's how many total letters were in those 6 students' names, and we divided it up equally among the 6 students so that each student had 5 letters or 5 counters in their cup. So again, this mean of 5 is the idea that you are sharing things equally among, in this case, the students. But the mean is the idea of a fair share. In terms of the balancing point, with the balancing point, when we say that something has a mean of 5, that means that everything balances out to 5. So what I'm going to do is I'm going to take these weights, and they all are the same weight, and right now our scale is balanced at our mean of 5 with nothing on there. As soon as I put Hannah's name on here, she had 6 letters in her name, you can see, whoop, we have lost balance here. And I'm going to continue putting the other students' names on here. I'm going to put this one's going to represent Elizabeth's name, length of 9 letters. And still obviously not balancing. This is Ben's name, 3 letters in his, and here's Ty. And, well, we've got a little bit of movement there, don't we? And then here's Jade's name. Don't have the balance that I'm wanting. And then 6 for Blaine. And what that does is that brings the scale back to its balancing point once I have all of the data values on there. Now, what I'd like to look at before we're finished with this video lesson is the important thing is that we have 30 letters and that they are divided up equally among 6 students. So I'm going to take these counters here, and I'm actually going to create a different data set for the students. And I'm going to put all of the counters out here in the middle. And what we have are definitely still the 30 counters. But I'm going to create a new data set. And I can do this pretty much any way I want. We'll not be using the students' name links, but I've got 30 letters here, and I have 6 students. So maybe I can have 3 in this cup, 3 in this cup, maybe 2 in this cup, perhaps 4 in this cup, maybe 4 in this cup. Ooh, that leaves me with a lot for this 6th cup. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Ooh, 14. So I'm going to put these 2, 4, 6, 8, 10, 12, 14 in that cup. And basically what I've done is I've taken all 30 letters and I've redistributed them among the 6 students. And I've changed the data values now. So now the data values are 3 in this cup, 3 in this cup, 2 in this cup, 4 in this cup, 4 in this cup, and 14 in the other cup. And once I place that data value on there, it brings us back into balance because I've used all 30 counters again, and the 30 counters are divided up among 6 cups, which of course each cup represents a student. So the counters represent letters, the cups represent students. 30 letters, again, divided up among 6 students, is still a mean of 5. And what I want you to understand is that there are quite a few different data values that we could have, 6 data values, different combinations of that, so to speak, where 6 data values can give you a mean of 5. But what's important is that the 6 data values would always, of course, in this case, have to add up to 30 and be divided up among 6 students to get that mean, the balancing point of 5, or the equaling out of the towers, the fair share of 5 in a cup. But I wanted you to see that, to have that understanding, so that when we talk about the process of adding everything up and dividing by how many different data values you have, you understand that it is more than just an answer, that indeed the answer you get is sharing all the items that you have equally, or it is this idea of balancing your data out.